Now we discuss about abnormal molar mass. Molar mass means molecular weight. Abnormal means not normal. That means different. So different molar mass or different molecular weight. If a solute undergoes either dissociation or association, then observed molecular weight. Observed molecular weight means when it is undergo either dissociation or association. That means after association or dissociation, we get molecular weight. That molecular weight is considered as observed molecular weight. Is less or greater than normal molecular weight. For example, if I take NaCl, its molecular weight is 58.5. When it is present in water, that means when NaCl is present in water, it becomes Na plus and Cl minus ions. We know that already. Then that means we can say that here before reaction we have only one NaCl, that means one molecule, that means one particle. After reaction we have two particles. So then its molecular weight becomes 58.5 by 2. So this is the molecular weight of NaCl when it is present in water. One more example, take MgCl2. When it is present in water, we get Mg plus 2 and 2 Cl minus ions. Then its molecular weight is, the MgCl2 molecular weight is 95, by here particles is 3. So what we have to do here, when these substances present in water, we get some particles. So we should divide its molecular weight by its particles. That is called abnormal molar mass. That means we get a different molecular weight than expected molecular weight. So this is about abnormal molar mass. We take one more example. Take CH3COOH, that is acetic acid. I take two acetic acid molecules. When this acetic acid is present in benzene, then we get one particle or one molecule that is like this. That means here 2 CH3COOH molecules. These are individual molecules. Here it becomes one molecule. That means acetic acid molecules undergoes dimerization. Dimerization means two molecules becomes one molecule. Two same molecules become one molecule. This is called association. Why it is called association? When number of particles decreases after reaction, that is called association. In this case, observed molecular weight is 120, because here before actually we have 60, because acetic acid molecular weight is 60, but here two particles are there. Sorry, two particles undergoes association, it becomes one particle. So its one particle molecular weight is how much? 120. So 120 by how many particles? After reaction we have only one particle. So 120 by 1, that is 120. So this is all about abnormal molar mass. So here we have to know some more points, that is dissociation and association. Dissociation means if number of particles increases after reaction, that is called dissociation. Here one particle becomes two particles. That means one NaCl becomes one Na plus and Cl minus. These are particles. This is also particle. Here one particle becomes two particles. Here MgCl2, one particle becomes three particles. One Mg plus 2 and 2 Cl minus. These are three. That means after reaction, if number of particles increases, that is dissociation. After reaction, if number of particles decreases, that is association. So these two examples for dissociation. This is example for association. So dissociation, I repeat once again, dissociation means if number of particles increases after reaction, that is called dissociation. In this case, two particles before one. In this case, three before one. But here we have only one before two. If number of particles decreases after reaction, that is called association. So the point is, if solute undergoes either dissociation or association, its molecular weight, that means its observed molecular weight is less or greater than normal molecular weight. Example, NaCl present in water, its observed molecular weight is how much? 58.5. by 2. That means its molecular weight should be divided by number of particles present in given solution after completing the reaction. If MgCl2 is present in water, its observed molecular weight is 95 by 3. Similarly, if acetic acid is placed, just now I discussed already about this one, then its observed molecular weight is 120 by 1, 120. So this is about abnormal molar mass, simple concept. Next one, Vant Hoff factor. It is represented by I. It explains how much amount of solute undergoes dissociation or association. That is Vant Hoff factor. So it explains extent of dissociation or association of a solute in a given solution. There are some formulas regarding I value. These are normal molecular weight by observed molecular weight. This is one formula. One more formula, number of particles after dissociation or association by number of particles before dissociation or association. And one more formula, observed colligative property by normal colligative property. If you use any formula, we get same value. For example, I take NaCl value. The I value for NaCl is, we just calculate. I just calculate that I value by using this formula. So if you use first formula, that is normal molecular weight by observed molecular weight, then normal molecular weight of NaCl is 58.5. Observed molecular weight is, just now we told, 58.5 by 2. That means total value is 2. Suppose if you use this formula, then also we get same value, that is 2. Number of particles after dissociation or association. That means when NaCl is present in water, then we get 2 particles after dissociation, that is 2 by number of particles before dissociation, that means 1. So 2 by 1, then also we get same value. So this is very important for now. Next, one more example. Take MgCl2. The I value for MgCl2 is, its normal molar mass is 95. Observed molecular weight 95 by 3. Total value 3. So simply number of particles present in a given compound, that is considered as I value. So this is about Vant Hoff factor. Next, here some more points are there regarding Vant Hoff factor. That is, if I value greater than 1, it indicates that solute undergoes dissociation. If I value less than 1, solute undergoes association. If I equal to 1, solute neither undergoes dissociation or association. For example, take the same example, take NaCl. Here in this case, I value is 2. We have discussed just now how it is 2. That means here I value is greater than 1. So this indicates that NaCl undergoes dissociation. In MgCl2 case, I value is 3. This indicates that this also undergoes dissociation. But in case of acetic acid, its I value is acetic acid. That means what is the reaction? This is the reaction. 2CH3COOH gives rise to CH3COOH. So after reaction we have 1, before reaction we have 2. So what is the formula? If you use second formula, number of particles after dissociation, or you can use first formula also. So number of particles after dissociation. How many particles after dissociation? 1. By how many particles, number of particles before dissociation? How much? 2. So 1 by 2, we get 0.5. This indicates, this means it is less than 1. So this indicates that the acetic acid undergoes association. So here the point is, if I value greater than 1, the solute undergoes dissociation. If I value less than 1, the solute undergoes association. One more point, if I value is equal to 1, then the solute neither undergoes dissociation nor association. These 3 points are very important, and these points are also very important for competitive level. Next, for glucose, sucrose and urea, their I value is 1 when they are dissolved in water, because they do not undergo dissociation or association. These are very, very important points. Glucose, sucrose, urea, they just dissolve in water. They cannot undergo dissociation or association. So that for those 3, I value is equal to 1. This is very, very important bit. Next, some more points are there regarding Vant Hoff factor. That is, in order to correct the value of colligative properties, If solute undergoes either dissociation or association, the Vant Hoff explains following. That is RLVP. We know that already formulas for RLVP. In previous video we discussed all the formulas. RLVP, actual formula RLVP is equal to mole fraction of solute. Next, delta TB is equal to KB into M. Next, delta TF equal to KF into M. Pi equal to MRT. These are formulas for colligative properties. Now, if we put I value before that one, then the molecular weight of substances can be corrected. Simple. The molecular weight of substances can be corrected. That is the purpose of introducing I value in these colligative properties. Next, note RLVP, relative lowering of vapor pressure. Delta TB, elevation of boiling point. Delta TF, depression in freezing point. Pi, osmotic pressure. These four are colligative properties. All these colligative properties is directly proportional to number of particles. That means when number of particles increases, these four increases. That is why these four are called colligative properties. Here some more points are there. They are vapor pressure. VP means vapor pressure. FP means freezing point. Depression in freezing point is colligative property but not freezing point. So vapor pressure and freezing point both are decreases when number of particles increases. I told you already in vapor pressure concept. Vapor pressure means the pressure exerted by vapor when it is in equilibrium with surface of the liquid. That is called vapor pressure. If any solute substance is added to solvent, then what happens? The attraction between solute and solvent increases. If attractions increases, then those substances cannot undergo evaporation easily. If they do not undergo evaporation easily, then its vapor pressure decreases. So the point is, if number of particles increases, vapor pressure decreases. Similarly, freezing point. What is freezing point? The temperature at which liquid is converted into solid. That is called freezing point. For example, freezing point of water is 0 degrees centigrade. But if either NaCl or KCl, whatever the substance is added to water, its freezing point becomes less than 0 degrees centigrade. That means if number of particles increases, freezing point decreases. These are very important point. So we face so many problems based on this one in competitive level. So the problems is like this. Which of the following exhibits more vapor pressure? That means the following should have, we should find which one contain more vapor pressure. That means following should have less number of particles. That is the meaning of that one. If number of particles are less, then automatically it gets more vapor pressure. It exhibits more vapor pressure. That is the meaning of the one. So for example, take 0.1 m NaCl. So how will we calculate number of particles in this case? We just calculate like this: 0.1 into how many particles present in NaCl? 1 Na plus and Cl minus. That means 0.1 into 2. We calculate like this. So its value becomes 0.2. That means 0.2 particles are there in this one. That is the meaning of that one. Here 0.2 into 1 mg plus 2 into 2 Cl minus. That means totally 3. That means 0.2 into 3, nothing but 0.6. In third case, 0.1, I told you glucose never undergoes dissociation or association. So 0.1 into 1, 0.1. Here 0.1 into how many particles? 3 Na plus and 1 PO4 minus. That means total 4. So 0.4. So these numbers indicates number of particles present in respective compounds. So in all these cases, number of particles are less in third case. That means 0.1 m glucose. So this compound exhibits more vapor pressure. Or we can say that this compound exhibits more freezing point. But this compound exhibits less RLVP, less delta TB, less delta TF, less pi value. That means osmotic pressure. Sometimes we face the question, like this: which of the following exhibits more RLVP, or which of the following exhibits less depression in freezing point, or less elevation of boiling point. We face such type of questions. If any type of question is given, we just follow this method. So to solve these type of questions, you just remember this box. This is very very important. As number of particles increases, these 4 are increases, these 2 are decreases. Simply if you remember this one, we can solve any type of question like this. So this is all about solutions chapter. In this chapter we usually face numericals in CBSE level exams. So better to solve all numericals. I told you already, you just solve once again, that's all.